Okay, hey there guys, and welcome to this video on half equations. So in this video we're going to have a look at what half equations actually are. They are oxidation and or reduction of certain things. You're also going to make sure that you know that each half equation focuses on one particular ion. And finally we're going to have a look at combining half equations in order to form a full ionic equation. Okay, let's have a look straight away. Alright, so the best way is to jump in with an example, and here we have a displacement reaction. As before, if you don't know what a displacement reaction is, then please do go and have a look at my videos on those. So I'm going to assume you know exactly what these are. So the most important thing you can do when you're going to be constructing half equations is to have a look at the ions, right, or the elements and the ions, and see what's the charges on them. Okay. So, charges on the ions. Now, this is actually quite easy, okay? So, copper oxide, for example, is an ionic substance, so we can talk about the charges on each one. Now, if you have a look at copper in the periodic table, well, actually, don't bother having a look at it in the periodic table. It is a transition metal, but we can work out the charge on copper based on the fact that it is with one oxygen. Now, oxygen is in group 6, which means it gains 2 electrons to become a -2 charge, right? Oxide, or the oxide ion, has a -2 charge, and bear in mind it's 1 to 1. This means copper has a +2 charge, right? Any element on its own, so magnesium, any element which is completely on its own, always has a 0 charge, right? And that there's no exception to that. Then, if we go over to the right hand side, well, magnesium is now with oxygen, and magnesium you can look at in the periodic table because it's in group 2, so it has a +2 charge. Oxide still has a -2 charge because it's still an ionic compound, and copper now has a 0 charge, right? So the purpose of this is we can decide what has been reduced and we can decide what has been oxidized, okay? Because if we take a look, we can see that the charges on the copper have changed, so it's gone from +2 to 0. The charges on the magnesium have changed, it's gone from 0 to +2. The charges on the oxide has not changed whatsoever, it's stayed at -2, right? That's what we call a spectator ion, right? So the oxide, I'm just going to actually write that, the oxide is what we call a spectator ion. That means that it doesn't actually take part in oxidation or reduction, it just kind of sits there being an ion. Right, so, first of all, let's have a look at the reduction. Well, which one is being reduced? Well, the one being reduced is the one which has gained electrons, or the one whose charge has gone down. That's the way I like to remember it, because reduction means, obviously, to go down. If the charge has gone down, then it's a reduction. Well, copper has gone from being +2 to being 0. That is what's being reduced. So, the reduction is of copper, and so you start off with copper 2+ ions and it ends up as copper ions. And so what you do here, and there's two ways of doing this, right? One of them I don't like, one of them I do, is you add electrons to one side of the equation, right? It actually shows what's happening. And so in the reduction of copper, what's happening is the copper ions, are gaining electrons, right? They are gaining electrons. And how many do they have to gain to go from +2? Let me just move that closer. To go from +2 to 0, well, they have to gain 2 electrons, right? And then they'll become copper. Now, the other way of balancing a half equation, which I said I don't like, is you're allowed to actually minus electrons. Right? In the GCSE syllabus, you're allowed to minus electrons. Any other time you ever do anything like this, you will never write minus electrons. You'll always write plus electrons. And so my advice would be don't do it. Okay, so that's fine. That's balanced. Moving on to the oxidation. Well, the oxidation, okay, forms or goes from magnesium being an element to magnesium being magnesium 2+ ions. And so this is kind of the opposite. This is where you could do what I'm telling you not to, which is you could say, well, magnesium loses 2 electrons, right? So I could say -2 electrons. Now, you would actually get the marks for that. I don't like that because in any other scenario, you never put minus in a chemical equation or in any kind of chemical equation, right? So instead, the way to think about this is, yes, magnesium has lost 2 electrons, which means it breaks down to form magnesium 2+ ions and 2 electrons, right? And then you're not disobeying that rule. And so this is the better way of writing that half equation, but both of them are actually correct in the GCSE syllabus. So let's have a look at what we have. Well, this is actually what we have, right? We've got copper 2 plus 2 E minus makes copper, and magnesium makes magnesium 2 plus 2 E minus. Right, now notice that the number of electrons is equal. Okay, that's because this is fully balanced, right? If it's not balanced, or your number of electrons is not equal in either of these, then you need to balance it to make sure that they are. But in this case, it is. Now, how do I form, finally, the Ionic equation? Well, the Ionic equation is formed by adding these together, right? So, if I add those together, and I'm going to write this underneath, I'll write it lightly. You've got copper 2 plus 2 E minus, right? Copper 2 plus 2 E minus plus magnesium, right? Well, that forms copper plus, and then underneath magnesium 2 plus 2 E minus. Right, now what we can do is we can go through and we can say, well, electrons, 2 electrons on the left and 2 electrons on the right, they cancel each other out, and so our final answer is, I'll just write it thicker so you can see it, copper 2 plus magnesium makes copper plus magnesium 2 plus magnesium 2 plus, right? And this is actually the Ionic equation, right? I'll have a look at Ionic equations in a bit more detail in another video, but this is your Ionic equation. And why is that important? If we go back to our original, we'll notice that we haven't included the oxide at all. Reason being, the oxide ion has not changed its charge. It's not been oxidized or reduced, and so we don't actually include it in the Ionic equation. The Ionic equation only cares about things which have changed their charge, right? So we end up with this as our Ionic equation, and that is that. Okay, I'm going to stop there. I hope that was easy enough to follow. If you still have questions, feel free to post them in the box or give me a direct email. As usual, please like and subscribe because that really does help me out. And I look forward, of course, to seeing you in the next video.